Tutorial 2 here. A balloon is being inflated with a water supply of 0.6 meter cube per second. Find the rate of growth of the radius at the instant when R is equal to 0.5 meter. So in this situation, you need to creative to imagine the situation. We have a balloon. So and then we put a water inside this balloon. So for sure the balloon will expand. And the water inside this balloon is not compressed itself. So means that the density of the fluid is remain the same. So and then in this situation, we don't have any outlet here. So means that 100% of the mass that we put into this balloon will stay inside a balloon, but because the balloon is expandable, so the area here will become bigger and bigger. So this is the situation. So and then we write down the basic idea of Reynolds transfer theorem. So we have dN over dt, d dt, control volume rho d volume plus integration of rho vn and dA. So in this situation, okay, because we are using water to put inside the balloon, not a gas. So water, if we see here, the question asks us to calculate at R equals 0.5 meter. So R equals 0.5 meter means the volume will become fixed, because at R equals 0.5 meter, so the volume, there is only one volume of the balloon. So and then the only parameter left here is the rho, the density. So density, and we have time here, so we have d rho dt. So it is means that the changes of density along the time. So because we are using water here, so means that the density of water is not changed by time. So we assume that all these parameter here is actually will equal to 0. So now we have only these terms to be analyzed. So and then here the value of Vn is the velocity, but the question need to find the value of the RDT. So you need to again to analyze your situation. So we find that the balloon is keep increasing. So means that the value of R here, the value of radius will become bigger and bigger. So means that the value of R is changing with time. So dr dt here means the changes of radius along the time. So because radius is in meter and time is in second, so dr dt is actually reflect the velocity in this term, because the unit is meter per second. So and then we substitute the equation. So again, according to this one, so this is equal to 0. So according to this one, we need to evaluate the what happened on the surface. So we have one surface at inlet and we have one surface at the outlet. So means the total surface of the sphere. So and then we could write as this one. So for inlet, so we have rho negative V1 and A1. So the negative V1 here, because in this situation, so we found that the inlet velocity is from left to the right, but the n vector is from right to the left. So the fluid moving in opposite direction of the n direction. So we give it a negative sign in this situation. So and then for the second term means the evaluation for the surface of this one. So we could write as rho VR and AR. So VR and AR is this one. So we assume that the surface here will expand. So means that it will move from this point to this point. So this is the increment of the velocity according to r. So and then if the r increase, so means that the area is also increased. So we substitute into the vr here, which is the dr dt, and the a here, the cross-sectional area or the area for the balloon. So please do not use pi r square, because it is not the area of circular area, but it is the area of the sphere. So the equation to calculate the area of sphere is 4 pi r square. So and then we substitute all the value. So we know that the density of air is 1.23 kilogram per meter cube. So and then the radius here is given in the question, which is equal to 0.5. So and then we could calculate the dr dt here is in positive, means the radius will increase along the time, and the rate, mean the speed of that radius increase, is 0.19096 meter per second.